So here are 6 examples of polynomials. They're mixed up. They're not all one type or another based on the techniques we've learned. They're just 6 polynomials to factor. You can, if you want, try these on your own. So pause the video, or you can watch the video through. After we've done these 6, it's really about hitting the homework hard. The more you practice, the more you're going to get comfortable just knowing what to do with whatever polynomial gets thrown your way. So if you want to practice these on your own, pause at this point. If you want to just watch through the first time, here we go. All right, so first step, always look for something common. If we look at x squared minus 4x plus 2x minus 8, there is nothing common. There isn't an x in every term. There is no number other than 1 in every term. Next, ask yourself, how many terms do we have? We have 4 terms, 1, 2, 3, 4. So we're going to look at factoring this by grouping. By grouping, we're going to look at this being in 2 stages. We're going to look at the first 2 terms first. What's common there? There's an x squared common. Take that out, and we're going to have an x minus 4 left. And then in the next 2 terms, we have a 2 in common. So take the 2 out, and we're left with x minus 4. The x minus 4 in parentheses is common, so we take that all the way out to the front, and we're left with x squared plus 2. So that's the factoring by grouping method. At this stage, say to yourself, is there anything else I can factor? Do we have anything common that I missed? No, both these individual binomials have nothing common. And then look for a difference of squares. X minus 4, the x here is not squared, so I can't take that any further. And the x squared here is a square, but the 2 is not a perfect square. So this should be my final result. To check it, just FOIL it out. X times x squared is x cubed, plus outside is 2x, inside is negative 4x squared, and the last term's a minus 8. Can't collect any like terms here, but if you compare them to the original, that's exactly what we started with, so that does check. Next example, 16 minus x to the 4th. This polynomial is not in descending order. Do you see how the constant comes before the x raised to the 4th power? This is an example where you'd want to write this in descending order. So negative stays with the x to the 4th, and then 16 didn't have a sign in front of it, so it's implied to be positive 16. Next, factor, because this starts with a negative 1, factor a negative out. Now there's nothing else in common, so just factor a negative 1. So we're going to have x to the 4th minus 16. So factoring out a negative 1 from the whole thing changes signs. And then factor what's left. There's only 2 terms, so think difference of squares. X to the 4th is a difference of squares because it's x squared times x squared. 16 is 4 and 4. Make sure you have 1 of each sign. And then we can do one more thing. I'm running out of room here, so I'm going to come up here. This last binomial is also a difference of squares, so I can go a step further. Negative 1 times x squared plus 4. That one is the sum of squares and can't be factored, but the last one that I underlined, I can write as x plus 2 times x minus 2. So that would be the final result. I can't factor further. So that would be my answer. One note, a negative 1 could just be written as a negative. So that's how you typically see textbooks write it. If we wanted to check this, to check it, I might distribute the negative here and multiply these at the same time. We just want to slowly multiply things out. So negative x squared minus 4. And then if I FOIL these guys out, x squared minus 2x plus 2x minus 4. Middle terms cancel out because they add to 0. So I now have negative x squared minus 4 times x squared minus 4. Keep FOILing. Negative x squared times x squared is negative x to the 4th. Outside terms will be positive 4x squared. Inside terms would be negative 4x squared. And the last term's negative 4 times negative 4 is positive 16. So when I add up and collect like terms, the 2 middle terms go away. So I get negative x to the 4th plus 16, and that checks. That's exactly where I started, other than the order. All right, so we've had one polynomial with 4 terms, so we used grouping. We had one polynomial with 2 terms, so we ended up using the difference of squares. Our next few examples are trinomials. This first one is in descending order, so we can leave it as is, but we want to look for something common. 6, 21, and 18 all have a 3 in common. So take the 3 out before you go any further. 2x squared plus 7x plus 6. And then the trinomial that's left, you can either use an AC method or trial and error. I'm going to use trial and error, but you are welcome to use the AC method. Just go ahead and do it off to the side on scratch paper. 2x squared plus 7x plus 6. I'm going to factor the 2x squared to the first positions. 2x times x. Then I'm going to factor the 6. My first thought for the 6 is 2 and 3. So if I put the 2 here, do you see how I would have a common factor? And I don't have a common factor in the trinomial that's left after I factor the 3 out. So I don't want to put the 3 there, or the 2 there. I want to put the 2 over here and the 3 here. So let's check that. If I multiply this out, 2x times 2 is 4x. 3 times x is 3x. That does add up to the 7x in the middle, so that looks good. So I can't factor anything further in the trinomial because my x's aren't squared any longer. So at this point, we just check. Multiply the 3 into the 2x plus 3, so I get 6x plus 9, and then multiply that by foiling to x plus 2. So I get 6x squared plus 12x plus 9x plus 18 when I foil. 12x plus 9x is 21x. That's where I started, so that looks good. The next example is again a trinomial, but it's not in descending order this time, so rewrite it in descending order. Remember to carry the signs with the term that you're on. Here we have a negative to begin with, so we're going to want to make sure we factor a common negative out. And then we also have a 2 in common, so instead of factoring a -1, factor a -2. So when we do that, -2 taken out of the first term leaves x squared. Out of the second term, now it's common to try to start writing exactly the sign you see up above, but when you have a positive 10x divided by a -2, you're going to get a negative here, specifically -5x. So watch your signs when you factor a negative out. And then positive 72 divided by -2 is -36. All right, keep going. Factor the trinomial into binomials. Because this is an x squared, I can just split the x's directly, and it makes it easier. I don't have to guess and check or anything. I could just look at factors of 36 that add up to -5. So -1, 36, -2, 18, -3, 12, -4, 9. That, if I change the signs, would add up to -5. So I'm going to use a +4 and a -9. And at this point, looks like we're good, unless just need to check it. So if I want to check this, I would have -2 multiplied into the x plus 4, so -2x minus 8, and then FOIL that to x minus 9. -2x times x is -2x squared. Outside would be positive 18x. Inside would be -8x. Last would be positive 72. Collecting the like terms in the middle means I have positive 10x. If we compare those terms with where I started, there's the 72, the 10x is there and it's positive, and the -2x is there as well. So that checks. 2 more examples on this page. 9x squared plus 16x plus 4. We could use the AC method here for the trinomial. There is nothing common to take out at the beginning, so we could use an AC method or trial and error. But if you look closely, this first term is a square, and as well as the last term being a square. Remember, we practiced with perfect square trinomials. If you ever see squares on both positions, try out a perfect square, undoing the squares. So if we undo the square here, we get 3x for 9x squared. Undo the square for 4 and we get 2. Would that work? 3x times 2 would be 6x. If I double it, I would have 12x. Is that where I have in the middle? Nope. Unfortunately, that doesn't work. So we have to start over. And we will have to either use the AC method or trial and error. I used the trial and error method on the last one, so maybe I'll use the AC method on this one. So I know I'm going to have the product of two binomials, so I set up my parentheses. 9 times 4 is 36. That's the AC part. Factor 36 to see if I can get 16. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now what I want is something that adds up to 16. 1 and 36, no. 2 and 18 add up to 20. 3 and 12 add up to 15. 4 and 9 add up to 13. 6 and 6 add up to 12. Nothing adds up to 16. So it turns out I actually can't factor this at all. This would be prime. So here's an example of a prime polynomial. There was nothing common that I could take out at the beginning, and I tried looking for perfect squares, didn't work. Tried factoring in the normal way, doesn't work because it is prime. Last example, 5x squared y minus 20y cubed. Always look for something common first. There's a 5 in both terms. There's also a y in both terms. So I'm going to take the 5y out first. When I take a 5y from the first term, I'm left with x squared. When I take it from the second term, I'm going to get minus 4y squared. What's left on the inside of this parentheses are perfect squares. X squared, 4y squared, those are perfect squares, and the minus in between them means I've got the difference of squares that will factor. So I'm going to just take those squares and undo them, x and x, and then 2y and 2y, and we want to give conjugates, so 1 plus 1 minus. So to check this, first multiply the 5y into the first one. 5y times x, 5xy, plus 10y squared. Multiply that by x minus 2y. I'm running out of room, so I'm going to squeeze it in here if I can. 5xy times x is 5x squared y. Outside terms would be negative 10xy squared. Inside terms would be positive 10xy squared. And the last terms would be negative 20y cubed. These two in the middle cancel out. They add up to 0, so I have 5x squared y minus 20y cubed, which is exactly where I started, so that was my answer.